today we have our guest, Yash, Saxena. How voice and video are getting prioritized.
Here EDCA comes in the picture. Okay, so EDCA nothing but enhanced distributed channel access, and it is a heart of the QoS.
There is some element called T-spec. What is it and how it can help in QoS?
QoS, it's a whole architecture.
You also mentioned about TXOP limits previously. So what is that exactly?
TXOP, that is transmission opportunity. That is also one of the core part of QoS. Mostly we can say Wi-Fi efficiency.
What's your observation on various applications today? How many of them are properly tagging the DSCP as per the application use case?
Your desktop apps like Zoom, Teams, WebEx. So these are enterprise level, and they mostly and most of the time they tag the DSCP correctly. And except few apps, most of them are not like following these markings.
Have you come across any scenarios where you observed voice or video traffic taking a hit, even though QoS mechanisms are enabled?
Yes, very frequently. People have this misconception that if I enable QoS, now magically my voice and video will get the priority and I'm going.
Hey everybody, welcome to Weekly Wi-Fi Wisdom podcast series where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host, Sainad. I'm WLAN QA engineer at Candela Technologies. And today we have our guest, Yash Saxena, and he has been working as wireless systems engineer at Candela Technologies for well over 4 years now. And in today's episode, he is here to share all his experience and wisdom on Wi-Fi QoS mechanisms. So welcome, Yash. I'm glad that you are here. To share your knowledge with us. How are you doing?
Thanks, Sainath. Thanks for having me here. I'm really looking forward for this episode on QoS.
Yes. So let's get into the episode. So let's start with understanding what is Wi-Fi QoS itself and why was it introduced in the first place.
Yeah, so there are lots of definitions about QoS. We can jump on it later on. Before that, I would like to bring one really simple situation. Which pretty much everyone's seen in home at offices. Two users are on same network and user one streaming any video and user two suddenly start downloading any very big file. So that time the user one which enjoying any video will experience a buffers and the video resolution will get dropped down. So it looks like a completely random, but when we see technically it's not random at all. So these are the scenarios which push industry and us to go towards the QoS. So the core idea of QoS in Wi-Fi comes in 802.11e amendment, and the thing is, as we know, Wi-Fi is a contention based, right? So everyone shares the same airtime, and one device can transmit at a time because it's a Wi-Fi half duplex thing. So the actual problem arises when we understood that not all type of traffics can tolerate delay equally. Right. So video, voice, they need consistent low delay and low jitter. So whereas TCP download, it really doesn't care about it. And one more thing is, people doesn't really realize that Wi-Fi is fundamentally unfair by default. So if you disable the QoS and your client send 1500 byte packet at MCS 0, it might hog up your airtime or even starve out your latency sensitive flow, because Wi-Fi cost us not throughput, not at all. It's all about airtime, right? So this QoS gives us some categories like voice, video, best effort, background, and each of them have separate contention parameters, and which gives kind of guarantee to the users in a practical scenario that they will get the access to the medium on early basis. So this is specifically on the voice side. So And also like QoS is not any on and off feature. It's more of analyzing, controlling the probability and checking for the prioritization and scheduling. So like let's say if any slow client is on in a network, right, and it is what so if and it also not supports WMM, so AP will treat it as a legacy client, and that client might not get the advantages of enhanced rates or AMPDU aggregations. So these things might affect not only the prioritization performance as well, right? So that makes the QoS kind of mandatory from 802.11 and above standards. Okay, so because like this kind of performance degradation should not happen. We know Wi-Fi is kind of very random access based thing, but still the most significant advantages which who get is only voice and video because they are time sensitive. Why? Because we are giving them a always consistent access to the medium, and that's how we are stabilizing their jitter, right? And as you asked me the question, why we need to use QoS, and so the most important thing is we know about roaming, right? So if you're doing a voice roaming, even though your roaming is seamless, but your QoS tag is getting misplaced when you are moving to the new AP.
Because the other AP has some different QoS configuration.
Right. Okay. So if the DSCP marking or something is getting drop off during the roam, that time you will feel the break in your voice. Okay. So that even though the roaming is good, you won't call it as a seamless roaming because you're facing a kind of bad experience. Right. So yeah, this is what we can say on the QoS.
Yes. So from what I understand it's primarily introduced to prioritize latency sensitive application traffic. So they do not take the hit of continuous contention from the other clients. Let's get a little bit deeper into this. So before QoS, how were frames treated, and what are the parameters that you mentioned, like which can help voice or video get more priority? So what technicalities are involved? So how is this being achieved?
So you're talking me like how we were doing before this game.
Yeah, before how were the frames treated, and after QoS, how are voice and video getting higher priority?
Okay. So before WMM exists, and that is nothing but 802.11e, we were using the DCF mechanism, that is nothing but distributed coordinated function. And basically DCF provided us a single queue and for all type of traffics, and these all kind of traffics were using the same contention mechanism. There was no concept of your QoS queues or prioritization or access categories.
So that means whenever a person is having a voice call over IP, or whether somebody is downloading a movie and somebody is watching a video, everything goes on the same queue and everything is treated as the same kind of traffic.
Yeah, exactly. Because so in the DCF we know, or like every station, let's say one station is requesting for voice, another station requesting for background. But because of DCF, we don't know. We are not categorizing them, and we're just checking first sensing the medium and finding out the channel is idle or not. And for a duration, we are calling it as a DIFS, and to make it eligible to transmit, right? Then after that, it pick up a one random backup value from the range of contention windows. And last thing is it the whatever the random value is there on the counter, it will get decrement by 1 whenever the channel is idle. Only then only.
Yeah.
So, but whenever the counter find okay the medium is busy, it will get freeze out. Okay. So station wait till the value reaches to 0, then it transmits. And if different type of traffics are there, still they will have the same DIFS. They will pick up the same random backup value from the same contention window, fighting with the same medium in the same way. So it will give a collision in the end.
Yeah. Understood. Now, how QoS is addressing this? How voice and video are getting prioritized?
So, so here EDCA comes in a picture. Okay, so EDCA nothing but enhanced distributed channel access, and it is a heart of the QoS because whatever the prioritization mechanism we are setting up is sitting on the top of it. And so EDCA brings us, like you can say, introduce us with the 4 categories, access categories like voice, video, background, and best effort. And these all categories were mapped to the user priority from 0 to 7. The key point here is each access categories have their own DCF engines or own DCF parameters. So let's say your voice is like they are parallel streams. Okay, you're running the 4 streams at the same time. All these 4 streams can work parallelly, independently. Each of them will have different AIFs and the parameters. So I'll go in those parameters. So these parameters are mostly your AIFs, right? That is nothing but arbitrary interframe space.
This was a replacement to DIFS previously?
Yes. Okay. And after that, we got introduced with CW min and max. That's a contention window range. And your back off counter. And in the last, your TXOP, nothing but your transmission opportunity limit. Okay. So here the thing we need to remember is whenever any stream which has a shorter AIFS and smaller contention range, and other like compared to that, other stream has a kind of a longer AIFS and wider range. So the shorter one always will be the more aggressive to get the access of the median because it has to wait very less.
Their count timers are less.
So they have to wait for very less time. They will get more opportunity to access the medium, and that's how they get it.
Right. So the probability of them transmitting the frames are higher when compared to low priority traffic.
Right.
Mm-hmm. So what are the typical values of contention window for voice and some least priority traffic like best effort?
Typical values. So in the scenario wise, so let's say practically we mostly work on like voice background like that. So voice typically have 2 value for AIFS and the contention range is 3. For background, it goes for 7 as a AIF, like 7 as a AIFS and 15 as a your contention views.
Those are minimum contention window, right?
Yes, it's a range from
Yeah. So the lesser contention window and the lesser AIFS. So these are the 2 parameters that are actually helping traffic like voice and video get more access to the medium.
Yeah, they have to wait for less time.
Yeah, that makes total sense. This is one of the mechanisms that you mentioned, right? EDCA.
Exactly. There's another one also.
Yeah, I'm about to ask that. So are there any other mechanisms in Wi-Fi QoS and what are they? How do they work?
See, the thing is EDCA not only bring us the access categories, it also bought the TID, the traffic identifiers. Okay, so these all traffic identifiers were mapped to the each of the user priority. Okay, audience can refer to the standard page, that is RFC 325. Okay, so there we can see these TIDs are like mapped like 6 and 7 for voice. Okay, 5 and 4 for video, and 0 and 3 for best effort, and last 1 and 2 for background. Okay. Now, as I mentioned, another mechanism, right? There was another mechanism which we are calling as a HCCA. Okay, HCCA, that is a HCF coordinated channel access. Okay. So this mechanism is mostly based on polling based scheduling. Okay, and it promised us that it will provide a kind of deterministic latency. Okay, but because of its complicacy and for deployment, whatever the APs I have tested so far with the vendors, most of the vendors are going with the EDC mechanism and they are not adopting this HCCA.
HCCA is not in use in practicality.
Right.
Much
more on the theoretical side. Exactly.
Okay. So this came from online reading while I'm going through QoS. There is some element called T-spec.
Yeah.
So what is it and how it can help in QoS?
So QoS, it's a whole architecture, okay? And in this big architecture, the first block is your admission control. So T-spec is a part of WMM in admission control, okay? So in a simple words, we can explain like it's a contract between client and AP, okay? Where we rely on client to send the information about what is the exact intended packet or traffic it want to send to the AP, and then AP has to check its airtime. If it has enough bandwidth, then only it should accept it. Okay. then there are some certain information elements which the client has to send, like mean data rate of what client is expecting, your delay bound, your surplus bandwidth allowance for the safety, your normal to maximum MSDU size, okay, and so min phi rate. So these are the things client send to the AP first. Then AP go for the calculation of airtime, okay. After the computation, it check whether it has bandwidth. If it has, then it will accept. Otherwise, it will reject it.
Okay.
Okay. Now, so this is how the T-spec actually is working, right? So if we can take an example like you have a lots of devices connected to the same AP, and you disable the T-spec.
Mm-hmm.
And what will happen is AP is not giving any guarantee. There's no limit. Okay, the devices are keep coming. They are getting admission. And now what will happen? Let's say for this time we talk about the voice. Okay, all the traffics are dumping into the voice category by the AP. Whatever the devices are getting connected to it. What will happen is that particular type of traffic will blows up. We'll see a very big spike in jitter. Okay, there will be lots of retries, right? And so these things will cause a bad performance. So when we going to enable it, the moment we enable it, AP for every admission, AP keep on checking its airtime, utilization, bandwidth, and then once it reaches to some safety limit, it will start rejecting the devices to come.
Okay. So is T-spec exclusive to voice video categories or can also be sent by clients which are running rest of it in background?
No, they are common for all type of traffics.
Okay, sure.
It's more of like giving you the kind of a ticket. If you have this and you are in the flow of scheduling, you will get the priority as per your ticket. Okay. So it's like giving a ticket up and getting the scheduling and prioritization.
Right, understood. So it's not just exclusive to voice only. Yes. And you also mentioned about TXOP limits previously. So what is that exactly?
So TXOP, that is transmission opportunity, that is also one of the core part of QoS. Mostly we can say for Wi-Fi efficiency. See, let's say we we know now that client already come up with the AIFS, and it went for the back off. Then that's how client already got the access. After that, TXOP hold that client for some fixed duration. Okay. Now during that fixed duration, client can send a sequence of frames or multiple AMPDUs. Okay. So it's more a flow like you can say sending, then coming back for the contention, wait, send, wait again. Okay. If we don't have the TXOP. If now after having the TXOP, we have just you win the access to the medium, you get some time, you get to the send some burst packets, like come out of the medium. That's it. Okay.
So it's like burst of packets being sent in a contiguous manner instead of sending few, again going to contention, again sending few. So it's not doing that here, right? So I think the AP allocates the client a certain time, and within that time, it keeps on sending the frames, right?
Yeah.
Is that the right?
Yeah. So TXOP also have some certain values typically for every category. Okay. Voice have little less, video have little higher. Okay. And particularly this TXOP is very much useful when it comes to video traffic. That's the reason, because it has a longer TXOP duration.
Okay, so generally video is awarded more TXOP levels.
Right. Okay. It can send the multiple bursts at the same time, like 12 millisecond, 20 millisecond. It has the kind of that duration. And in a one go, it no need to come back to check the contention. Okay.
Understood. Yeah.
So like one more point is there on TXOP. So this is what we know as 802.11e perspective. Now, once this 802.11ax came, right, that time TXOP becomes more powerful. How? Because it got the OFDMA scheduling along with it.
Okay.
So now whenever the AP got the downlink, now AP can assign the multiple RUs to the different clients. It can send the the multiple traffics parallelly on the clients, and it's just like many transmissions are happening using same TXIP, right?
Within a single TXO, multiple clients are involving with the help of OIP.
OFDM scheduling, right? And similarly, when we are going towards a BE standard, Wi-Fi 7, so we heard about MLO, multi-link operation. So that's make it more critical because now TXOP is not restricted to the one channel or one radio. Same TXOP can be used for the 2G, 5G, and 6G
across multiple bands. Understood. So I've seen a few APs claiming that I support dynamic QoS. So what's dynamic QoS and how is it different from the QoS that we have talked about till now?
So for that, first we need to understand what is traditional QoS we were using. So that is mostly specifies based on that application marking of the DSCP correctly or not. Okay. Now let's say we are on this podcast. We are our traffic is going on as a video traffic. It got some tag and it got some user priority, and then of course it will fall into the video category. And if it's happening, it's fine.
Yeah.
But if we are not tagging any to this traffic, we are not marking any DSCP. That time by default it will go under best effort. That we usually see mostly on the AP side. And now what happens is with the traditional one, basically the problem arises that we should not assume that all the applications are tagging the DSCP correctly. That's the problem in the modern Wi-Fi world mostly. When we see this problem was not there in earlier days because we were having the enterprise level. Okay, the enterprise level was having some your SCOM and your Spectra link, and they were marking the DSCP correctly. But these days, these Androids, iOS apps, your browsers, your OTTs, they're not marking of it correctly. They are stripping it down. Okay.
Yeah.
So we should not rely 100% on the DSCP. If we do, somewhere we will not using the purpose of QoS.
Yeah. I was about to ask that because I have seen few applications myself, like for instance, take for example a CC camera. So it will upload the video traffic that it is seeing, right? So when I observe the IP packet, I expected the DSCP tag to match something that correlates with video in the WMM parameters. But I see it doing DSCP default, which maps to best effort. So what's your observation on various applications today? How many of them are properly tagging the DSCP as per the application use case? So if I'm having a voice call, I'm having the DSCP tagged in accordance with voice. Do you see most of them not tagging as expected or tagging as expected? What's your take?
This is one of an interesting question I can say in the QoS we have. So because the practical behavior in the world is very inconsistent. So when we talk about your desktop apps like Zoom, Teams, WebEx, so these are enterprise level, and they mostly and most of the time they tag the DSCP correctly. Okay. Now when we goes towards the mobile applications, there are some OEMs, there are many variables, and except few apps, most of them are not taking up following this marking. And even though if they mark up correctly, if you are using any VPN, there the tunneling will override the DSCP. Okay, because tunneling always encapsulates the headers. It changes the headers, and it's where the DSCP gets changed. Okay,
it gets overridden with the VPNs.
Okay. Even like if VPN also have this influence nature on the marking up on the DSCP. And when it comes to OTT, most of the time your Netflix, WhatsApp, Instagram, these applications by default always you will find it as a under best effort. I do also saw them as a best effort. Okay. So that's the reason we should not rely on the DSCP marking 100%. We should. There's a solution for that. So that's how we come up with the dynamic QoS. Okay.
Yeah. So dynamic. How does dynamic QoS help here? So it identifies the application and overrides the DSCP marking, or
so Dynamic QoS is more of like AP and already knew it, that I am not going to wait for the application to give me the mark of DSCP.
Okay.
I'm going to analyze it by myself. Now, how it going to do it? Now, there the vendors comes, right? Now, vendors have some defined algorithms. How they're defining? Now, there are some basic 3 parameters. Now, first one is your RTP and payload size, like pattern analysis.
Okay.
Now that, like, what is the interval of that pattern? The second one is your packet analysis. Okay. The third, the most important one is your flow behavior. Okay. What's the behavior of your traffic? The flow. Now, when we come to the first one, okay, let's say you told your AP if you are receiving any fixed packet intervals of 20 milliseconds,
Okay.
and consistent payload size, then treat it as a under voice. That's it. Now AP will go with that algorithm, right?
Right.
It's not only about there are various variables here also. Now some vendors go with the FQDN, kind of they manually set the DSCP. They go for the bulk intervals, okay, and some goes with this packet intervals, right? The most important one is the flow behavior, because your voice, your video, like, see, every applications, every type of traffic, they have some their typical behavior.
Right.
When we come to a common conclusion, we always find some a known pattern of a voice and video. For example, voice will have always a small packets, video will have large packets. Voice will have the consistent the payload size, and but, or you can say bit rate is very consistent on the voice, but when it comes to video, the bit rate is very frequent and in bursty nature, because a user can go to any of the resolution it wants to stream the video.
True.
And so these are the reasons. If AP detects, okay, the bitrate is consistent and your packs are small, okay, it's a voice only. So we have this easier method to analyze the flow and put them into the bucket wherever they belongs to, as per the experience.
It's more of analyzing the packets and few parameters like bitrate and payload size and the nature of the traffic, and then deciding which of the 4 packets that it falls to, and then mapping accordingly.
Exactly.
I think that's some intelligent analysis.
Right. So even on the WhatsApp, if you use, so in any time if you are seeing best effort or while testing, if we want a good experience, we need to make it under dynamic QoS, okay, so that it can, because why I'm saying, see, people sometimes says best effort, it's fine, anyhow it's coming up with a good throughput, we are not facing any issues and all, right?
But the part they miss is the latency.
Latency, because and when it will come, when it's a congestion in the network, it's a load there in the network. When this scenario occurs, that time you will feel the difference between the best effort and voice.
True. Yeah. Now we have talked about many mechanisms so far. So with all these mechanisms in place, have you come across any scenarios where you observed voice or video traffic taking a hit, even though QoS mechanisms are enabled?
Yes, very frequently.
Very frequently.
Yeah. So sometimes what happens is, it depends upon lab environment. Okay. If I say a quick answer to it, definitely, and interestingly, the reason is not QoS.
Okay.
The reason is RF environment. Okay. So people have this misconception that if I enable QoS, now magically my voice and video will get the priority and I'm going to get the very good throughput. But we need to understand that AP cannot create its own airtime. It can, QoS especially can do the scheduling for whatever the physical medium is there available for it. And QoS is most of the MAC layer scheduling thing, right? It will tell you that, okay, this packet will transmit first, this packet will transmit later, but it has do nothing to about you, like you have low SNR, you don't have a clean airtime, okay, you have less bandwidth. So these factors are not have any relation with the QoS. So right. So these are all physical layer things, and QoS has nothing to do with it. Okay, and the main reasons are, or you can say the common reasons we face this kind of issues are low SNR.
Okay.
Because of low SNR, even though you're running the voice traffic, if your MCS rate is low, the packet will deliver in a slow speed, right?
Right.
The second one is your retries. Okay, let's say you're running a voice traffic and you are encountering three retries or four retries. You already you cross the boundary for the voice traffic. It cannot tolerate this many retries,
Right.
right? And other than that, we have some common things like that adjacent channel interference, especially when we are using the 5 gigahertz band and operating on 40 megahertz and 80 megahertz bandwidth, and your co-channel interference. So these are the common factors which we are used to see these kind of issues.
Right. So QoS unfortunately cannot help if you have bad RF, as you mentioned, with bad phi metrics.
If you want to see the intended quality of QoS, we need to make sure this SNR should be high and we should have a stable environment of RF.
True. Now, since you have talked about some of the issues you have mentioned, tell us one particular issue that you found particularly hard to troubleshoot or debug, and what's your approach of debugging that trickiest bug that you have come across?
So there are lots of QoS bugs.
Pick one. Pick some big one. Yeah.
So if I look and remember, I have one bug to discuss that we have seen one scenario in our testing where we enable the QoS on the AP, okay, and we are running the voice traffic, and the expected behavior is it should tag with the same DSCP and all the WMMIEs follow the EDC parameters, the values should be correct, and those control fields should be correct, and that's what we expected. But the throughput was we are getting pretty low compared as expected of voice. Then we checked on AP side, we are not finding it anything else, and then we check its logs, and then there we have seen dynamic use was also enabled there. Okay. Now what happening is, even though we told that voice traffic is this is voice traffic to the AP and we enable the QoS, but the flow of the traffic is coming under the video when as per the dynamic use.
Okay.
Okay.
So the algorithm is interpreting it wrongly.
Yes. The flow is of, let's say flow is of video and the actual packet is of voice. Dynamic QoS is interfering here because of the flow behavior, but actual AP is saying no, this is voice only. So there the you can say conflict happened. Okay, and that's where we saw that one same packet is getting splitting between voice and video, and that was leading us towards the low performance, low throughput. And so this is the one of the case, and this issue we have seen after we sniffed on the wired side specifically, and we checked the QoS control fields, and we found out, okay, during these data packets, some of them are having this field, some of them are having this mapping, and that's where the mapping is getting misinterpreted, and that's how we understood, okay, it's both of them the cause.
Right. So now if somebody comes to you and ask, how do I test QoS? So to ensure that the AP is working as expected, what test case would you suggest?
So when it comes to testing QoS, the first most important thing is QoS is the feature which we need to test only in the load scenario. Okay, if you're checking with only 4 clients or some less clients, we are not going to see anything. We have to make the scenario as a load one.
And why is that exactly? Because on a baseline, let's say you only
because we won't see the latency playing a role here, right? We need to see how the latency and jitter are showing their performance when it comes to the different streams.
So you need to pump more frames so that contention for airtime is high.
We can make it. How we can make it is ideally we need to make sure that to run at least one RTP or voice traffic, one 8K video stream, and let's say your one TCP file and your UDP, that burst, or you can say UDP flood, Okay, that is optional, but you can include it as your testing input. And once you do that, then only you will find out that get the proper inputs after this testing. The inputs and the values you will find will be useful, and those will be related to jitter, your MCS, your packet loss, latency, and those things, right? Your airtime sharing. So those values will be really useful once you have this scenario with all these, these kind of traffics. If you will run, then only your airtime will get congested, and you will see how it is working on that behind. Also, along with that, in the end, we need to check for the wired and wireless packets, and we need to lively do the packet sniffing, and on we need to keep on checking the ADCIs, they're mapping correctly or not. Okay, the DSCP markings, and so these are the basic things we have to look into.
Right. I think lots of practical insights from you. So, if you have anything to share, somebody who wants to make sure that my QoS should be working fine, and my voice traffic should always get prioritized. What are few practical suggestions that you would give to ensure a smooth QoS experience? You have already mentioned that taking care of good RF, that's one thing. So can you extend few more suggestions like that?
Yeah. So first and very first thing is to always check for DSCP mapping, because if its starting is not correct, then we cannot expect anything good in the end. Second one is as you mentioned, your RF should be always strong, and of course we need to test in the load scenarios. These are the three basic things, and we need to keep in mind before testing QoS. And yeah, this is the things we can say.
Understood. Yeah. Thank you so much, Yash, for all your practical insights that you have from your experience and sharing with our audience. I hope
Thank
all of them will find it useful. And thank you for coming over, and thank you for your time. So that's all, everybody, on QoS. If you have any questions related to QoS on what he spoke, please put them in the comments below so that he can answer. I'll make sure he sees your comments if you comment.
Yeah, sure.
So if you like the video, please like, share, subscribe, and continue watching for more. More episodes are coming out soon. Yeah, stay tuned, and we'll see you in the next episode. Thank you.